In this notebook, we will use a popular database called IRIS. It features 50 iris flowers and their classification into 3 species. We will use the IRIS database from Kaggle in SQLite format for the rest of the notebook. If you could locate the notebook in your Week 8 folder, it's called Working with Databases. The notebook on top has a Kaggle link, kaggle.com UCIML/iris. You need to download the data from this link. The dataset is called database.sqlite, and it should be placed in the data/iris folder you have for Week 8. So now please stop the video, go to this link, and download the dataset. Assuming you stopped the video and downloaded the dataset before we move on, please run the next 2 code cells to check that you were successfully able to complete this step. So what's in those next 2 cells? The first one says import OS, and it actually brings the data.iris to an object called data.iris folder content. And the error message is a string that we would display if that wasn't there or the database.sqlite wasn't in that folder. So we are checking, we put an assertion called database SQLite in data.iris folder, error message. Please note that this error message operation shows an assertion or a good way of capturing errors in a program using an assert statement. Assert statements generally help you locate or identify bugs in your Python programs as a way of creating such built-in tests. So if you do a lot of testing, you'll actually do a lot of assert statements. Okay, assuming this worked great, let's move on to interacting with our database, the database.sqlite that you downloaded. We will import SQLite first. SQLite 3 is a Python module that allows us to do easy SQL operations. And we'll use that to connect to database.sqlite in that iris folder that we placed. Now we have a connection object, and we'll use this connection object to get a cursor object. That cursor object is actually our interface to the database. Before we move on, I'd like to also mention that SQLite comes with your standard Python, so it's not a library that you need to go and install separately. So it's a pretty easy and nice way of interacting with a simple database using simple database queries. Let's look at the type of that cursor object, right? It's the type cursor. So as I mentioned, this is our interface to the database, and mostly through the execute method of this cursor object, we'll be able to run any SQL query on our database in our database like SQLite that we have connected to using that connection object. For example, we can get a list of all tables saved into the database. This is done by reading the column name from the SQL master metadata table. So SQLite_master, we are reading from that. That's the metadata table for our database. And the output of this execution will be turned into an iterator. So if I just ran cursor.execute select blah, I would get an iterator. So now I'm using that iterator in a for loop to print each row. So in the case of the iris database, we only have one table, so we get that one back. As you see, it's called iris here. A shortcut to directly execute the query and gather the results is also called the fetch all method. So we can retrieve data from a particular table using a select query, or in this case SQL master, and fetch it all without that for loop. We should get a list out of this. I can do a similar thing with another database, the data table, like from IRIS table instead of the SQLite master, it's going to definitely return a list, right? If we print the sample of this type, we see that it's of a class list. We could work with this list, but it's very low level and not the most efficient way. We also remember that limit that we mentioned in the video just prior to this hands-on session. This last query statement, select star from iris limit 3, brings us the top 3 rows. You can change it to 5 or 20 or however rows you'd like and execute that. And if we display that, now we see all those 20 rows in our list that was created as a result of fetch all. And it's a list data structure. We know how to work with that data structure, right? So we get the columns for this list. Okay, so although it's possible to create many operations like that using SQLite, Pandas actually, as you know, provides a more intuitive and efficient way to interact with the data. So like we did for our European soccer database before, we will now use Pandas read SQL query function to load the data in the iris table to a Pandas data frame. You've seen this before, but let's review now with the knowledge of SQLite again what's going on here, right? We have imported Pandas as PD, and here to a data frame object called iris data, we use the read SQL query method from Pandas, and we give that a SQL query, a select query, select star from iris. Now you know what that means, and the connection object. So through this connection token and the query, Pandas knows, or the read SQL query function knows, how to get the results of that query and create a data frame for us. Let's run these. Let's first import Pandas, iris data. We are loading the data now. Let's get the first 5 using our head operation. And we can also do the D types of each column. We see that this is simple. You know now how to work with Pandas. We can also create more complex queries that constrains the data we load into the data frame. Because if the data is big, large, the table is maybe a lot of rows, columns, and we maybe want to pick a part of it, we can actually create constraints using those SQL queries. Now that you know what you know about these select queries, here, for example, it's the exact same, but we are selecting iris setosa rather than all 3 species. We have a query that says select star from iris, where species is iris setosa. So once we execute this, we'll see that we only have 1 species in our resulting data frame. If we actually go and say iris setosa dot shape, and our earlier one was iris data, and let's do a print. And print iris data dot shape, we'll see that we have 1/3 in our iris setosa table. So we have 50 of each species in the iris database, 150 rows. And with this new query, we were able to slice out, so to say, in a relational query sense, the first or the 50 that belongs to the iris setosa species. Although we can expand on these SQL queries, let's stop here for simplicity. I, as usual, encourage you to build an exercise for yourself using this database For example, using the IRIS database for building models using the machine learning libraries we discussed last week. In fact, the IRIS database is commonly used to demonstrate different machine learning algorithms. So this is a good time to introduce this data set, and hoping you will use it to create exercises for yourself.